Hello and welcome back. Let us try to understand support vector machine, one of the best algorithms in machine learning. This algorithm can be used to solve a classification or regression problem, but mostly used with classification problems. And the algorithm can work with linear and non-linear datasets. That means when the input variable is linearly related to target variable or non-linearly related to target variable, the algorithm can solve the problem. The hypothesis function is as like this: W transpose x plus b. W transpose x is a linear combination of all input variables. Like in our linear regression, where we use it to calculate the linear combination of all the input variables, and we'll be finding these weights, right? The thetas. Like that here, it denoted with W. And b is the bias term, which is nothing but theta 0 in your linear regression. But the algorithm works in a little different way. If the sign of W transpose x is positive, that means greater than or equal to 0, the record belongs to 1. If it is negative, the record belongs to 0. And the algorithm is going to find the W's in such a way, when you pass the train set, the algorithm is going to find the W's in such a way that for the positive records, it always gives you a number greater than or equal to 0, and for the negative records, it always gives you a number less than 0. That's the finding, or that's the understanding, or that's the pattern recognition SVM algorithm is going to do. SVM algorithm is generally known as large margin classifier because it actually tries to distinguish two different classes with a large margin rather than a single decision boundary. In logistic regression, we have seen that it is going to, the logistic regression is going to do a single decision boundary, which is going to distinguish two classes. Above the boundary are one class and below the boundary are another class. In here also the same thing happens, but it is going to take two data points from two different classes and call them as support vectors, and based on those two data points, it is going to do the decision boundary. In a moment, we will see some pictorial representation. See, the closest data points to decision boundary are known as support vectors. So, what that means, we will see it in the next slide. So, if you see this, there are red circles and red squares and blue circles. Suppose that there are two different classes. Suppose that two different there are m number of data points belonging to two different classes. If algorithm chooses this data point as support vector and this data point as support vector from two different classes, they are kind of special candidates from two different classes. You can imagine them as special candidates from two different classes. If it chooses this as a support vector from red squares, and this as a support vector from blue circle, right? It is going to do a vector, and then exactly in the middle of it is going to do a decision boundary. Okay, so there are three possibilities here. If it chooses this red square as the support vector and this one as the support vector, the decision boundary is going to be in a certain angle. And if here it does it, right, if it chooses this data point is support vector and this data point is support vector, the decision boundary is going to be in a different angle. I think you are observing that angle is changing. The angle is changing because of the support vectors changed. Okay, and if it chooses these two data points as support vectors from red side and this one from blue side, the decision boundaries angle change a little more, right? But when you observe these three diagrams, here the decision boundary is the margin is too high when compared to this margin and this margin and this margin. This margin is too high. So support vector machine algorithm will choose these data points as support vectors rather than these two. So these three are the possible models that support vector can build, but ultimately the SVM algorithm will actually come out with this kind of setup because the margin is large. So that's where support vector machine is always called as large margin classifier. It always tries to choose the support vectors in such a way that the margin is going to be large. What is the advantage of it? If the margin is large, it can distinguish the two different classes very clearly. If you see this, it is a little close, right? If a new data point from test set comes somewhere here, right, there is a chance that the model will make a wrong prediction somewhere here. But if the same data point is there here, right, most probably it will be predicted properly on the test set. So if the margin is large, there is a possibility that on test set the model will work good. Okay, so support vector machine is called as large margin classifier because of this reason. It chooses the support vectors and then tries to do the decision boundary. In logistic regression, we are directly finding the decision boundary. And when you find, when you actually do a large margin classifier, the edge cases, if the data points are on the edge, right, there is a possibility that they'll fall onto the right side when you choose a large margin classifier like this. So that is the, that is a high level view of a support vector machine and how it works and how it chooses the support vectors. It always chooses the support vectors which will give you a large margin like this. So let us meet in the next session and understand more about the cost function and hyperparameter tuning. Once after understanding all these things, we will do a coding example. Thank you.